We have a continuous function, f of x, from a to b. We want to find the area under this f from a to b. So that the area under f from a to b, we call it a. Okay. We will not only find a value, but we will find the formula. That formula is called the fundamental theorem of calculus. Now, how do we start? First, I define a function a of x. A of x is an area under f from a to x. So that means this area is called a of x. Well, is that clear? Yeah. This area is a of x under f from a to x. Now, if x increases a very small amount, which is called delta x, so this point is x plus delta x, right? So this piece of increase, due to the increase of x, I call delta A. Delta A. Now, we analyze this delta A by magnifying a million times the width. Okay, this is delta A. We want to find delta A. Now, in this delta A, the width is delta x. The width. The height, because the function is a variance, therefore the height is different. You see, it might be different everywhere from x to x plus delta x, but definitely there is an average height. That average height is called f over x bar, which means the height, the function value is based on x bar. This x bar must exist somewhere in this tiny interval. That height is the average height of this small, very tiny slice. Then this delta A, that area, is equal to the height, which is f over x bar, somewhere in x bar, times delta x, right? The height times the width is the area of this slice. And then delta A over delta x is f over x bar. Okay. Then as this is important, as delta x approaches to 0, as delta x approaches to 0, which means the point, this is going to 0. This point moves towards x. If this point moves towards x, then f of x bar is f of x, right? This height is f of x. The left-hand side is the derivative. Of a with respect to x is equal to f of x. That is the key. This is the key step. Okay, I don't mind repeat again. As delta x goes to 0, delta A over delta x is the derivative A with respect to x. That's the definition of a derivative, right? But at the same time that the x bar, when this one goes to 0, x bar is the x, right? This point must move to x. Now, then, how do we find A? Then A of x is the antiderivative of this, right? We're looking for antiderivative of A. You can see that's the definition of an antiderivative, which is equal to f of x plus c, right? This capital F of x is the antiderivative of a small f of x. Now then, A over A, the area under F from A to A. Of course, there's no area, right? The area is 0, which is equal to f of A plus c is equal to 0. So this means that f of A is negative c, right? At the same time that A of B is equal to f of a b plus c. C is a negative a, so it becomes minus f of a, right? And this is the area we are looking for. The area under f from A to B is A of B. Okay, that one we give a new notation. That's a definite integral from A to B f of x dx. We just given this A, the area under f from A to B, a new notation that is a definite integral of f of x dx from A to B. So that is the fundamental theorem of a calculus. X is equal to f of x. That is the way to write f of a b minus f of a. This is the fundamental theorem of a calculus. And the proof is very simple, is very understandable, clear, very concise. Okay, you know how important this formula is. Okay, this is also called Newton-Leibniz formula. Okay, thank you for your watching.